Welcome to This Explainer. Today, we're unlocking a force of nature so incredibly massive, it literally dictates the weather for billions of us. I'm talking about ENSO, the climate's absolute biggest seesaw. Now, think about this for a second. How in the world does a slight warming right in the middle of the Pacific Ocean, sometimes we're just talking a fraction of a degree, how does that manage to trigger catastrophic floods in one hemisphere and then devastating wildfires in another, thousands of miles away? It's a massive global puzzle, and the stakes for figuring it out have literally never been higher. Okay, let's dive right into this. We're going to start by breaking down this massive climate seesaw, meet the different ENSO phases, and track those global weather ripple effects. After that, we'll look at the climate change twist, and finally, what we all need to do to brace for these extreme weather shifts. Let's start with part one, the climate's biggest seesaw. Meet ENSO. That stands for the El Niño-Southern Oscillation. Basically, this is the main engine of our global weather. It operates on this irregular 2 to 7 year heartbeat, and whenever it beats, it triggers massive, wide-scale shifts in ocean temperatures, winds, and rainfall all across the tropical Pacific. Let's look at the baseline first, what we call the ENSO neutral state. You see those blue arrows? They represent the strong trade winds. Think of them like a giant, continuous fan blowing west along the equator. They're physically pushing and piling up warm surface water over near Indonesia and the Western Pacific. Because all that warm water is getting shoved west, freezing cold water from deep down in the ocean actually gets drawn right up to the surface in the east, just off the coast of South America. That dividing line you see sloping upwards between the warm surface water and the cold deep water, that's the thermocline. And hey, where you have warm water, you get rising air, clouds, and rain, which is exactly why Indonesia usually gets drenched with so much normal tropical rainfall. But what happens when those winds falter? Well, we enter El Niño. Without that giant fan holding everything back, that massive pool of warm water effectively just sloshes eastward back across the vast Pacific, kind of like water in a giant bathtub. As it shifts east, it flattens out that thermocline and completely cuts off that cold water upwelling. But here's the real kicker. Those massive storm clouds and tropical rains that normally hang out over Indonesia, they follow the warm water east, completely scrambling the atmosphere. And then, of course, we have the extreme opposite, La Niña. In this phase, the trade winds go absolutely into overdrive. They blow way stronger than normal from east to west. This supercharged push jams the warm water even further to the western edge of the Pacific, dumping heavy, intense rainfall right over Indonesia and Malaysia. Meanwhile, back in the eastern Pacific, things get an extreme chill as even more cooler than average deep water surges up to the surface. It's a massive planetary scale seesaw just continuously tilting back and forth. Moving on to part two. Meet the ENSO phases. Let's see how we actually track this thing. To officially declare which phase we're in, scientists focus their attention right here. This rectangular box sitting directly on the equator is the Niño 3.4 region. NOAA uses this exact patch of ocean as our vital planetary thermometer. They track the average sea surface temperature here over a running 3-month period and then compare it to a 30-year historical average to calculate something called the Oceanic Niño Index. Now, here is the absolutely mind-blowing part. The magic number is just half a degree Celsius. If the temperature in that El Niño 3.4 region ticks up from the historical average by just positive 0.5 degrees, boom, it's officially an El Niño. And if it drops by negative 0.5 degrees, we're in a La Niña. Honestly, it is just astonishing to think that a temperature shift of half a degree in one specific remote stretch of the ocean is quite literally all it takes to trigger massive atmospheric chaos worldwide. Which brings us to part three, global weather ripple effects. Let's talk about atmospheric bridges. This is where we have to look up to the sky. These shifts in the ocean create what meteorologists call teleconnections. Think of them as atmospheric bridges linking the remote tropics right to your own backyard. Because El Niño and La Niña physically move where those massive tropical storm clouds sit, they literally alter the pressure gradients of our upper atmosphere. That in turn shifts the jet streams. Take the US during wintertime, for example. These two phases create completely opposite realities for us. Check out an El Niño winter. Notice that Pacific jet stream highlighted in red? It shifts way south. It becomes much stronger and more persistent, dragging this amplified storm track and a whole lot of heavy rain across the southern US, while leaving the north unusually mild and warmer than average. But flip that over to a La Niña winter, and it's a completely different story. The jet stream violently contorts into this massive looping wave. It reaches up and drags freezing, stormy polar air right down into the northern states, plunging the north into the deep freeze, while leaving the south abnormally warm and totally parched. Two different ocean temperatures, two completely different sets of atmospheric ripples. So that's the baseline. But we really need to ask the multi-trillion-dollar question right now. What exactly happens to this delicate planetary seesaw when the entire globe is warming up? That leads us right into part 4, the climate change twist. According to some really cutting-edge findings published in the journal Nature, human-caused warming is actively altering the fundamental mechanics of the Pacific Ocean. Now look, ancient corals and sediment records show us that ENSO has always fluctuated. It even weakened during the mid-Holocene era. But something highly unusual has been happening since the 1950s. We're seeing a 20 to 25% intensification of these ENSO swings compared to previous centuries. The main culprit? Greenhouse gases are trapping heat right at the surface, increasing something called ocean stratification. Basically, the ocean is separating into distinct layers, meaning that top layer reacts far more aggressively to any slight change in the wind. And because of this extreme stratification, the latest state-of-the-art climate models are projecting a 15% surge in Eastern Pacific ENSO variants as the century goes on. The models are all in agreement here. The planetary seesaw is swinging wider, and it's swinging a whole lot harder. Finally, part 5, brace for extreme weather. So what does an amplified, supercharged system actually mean for all of us? First off, those atmospheric bridges we talked about, they are physically shifting eastward because the Eastern Pacific is warming up faster. The El Niño storm clouds are moving right along with it. This completely redraws global rainfall maps, meaning we're going to see more intense, prolonged rain anomalies slamming into places like the North American West Coast. And the compounding risks here are severe. We are looking directly at a future filled with whiplash years, meaning we could plunge from an extreme El Niño one year straight into a devastating La Niña the very next. This whiplash expands the geographical reach of killer droughts and catastrophic floods, and it drastically increases the threat of tropical cyclones for incredibly vulnerable island nations like Fiji, Vanuatu, the Marshall Islands, and Hawaii. The bottom line is this: the fundamental physics of the Pacific Ocean are responding to a warmer world. And those amplified ripples, they're coming for our coastlines, our farmlands, and our cities. So when the climate's absolute biggest seesaw starts swinging harder and faster, we have to look really closely at our own communities and ask, is our local infrastructure truly ready for the drop? Thanks so much for joining me on this explainer. And as always, keep questioning the world around you.